Measurement, which is circle theory, measurement, geometry, and trigonometry. It says the diagram below not drawn to scale shows a circle with center O. The vertices H, J, K, and L are quadrilateral, line a circumference of a circle, and PKM is a tangent to the circle at K. The measurement of the angle HJK is 20 and JKH is 50. Calculate giving reasons for each step of your answer the measurement HKL. HKL, this angle I want. Let's see how we're going to find this angle. Now, first thing, HO, let me see this, HO and OK are what's known as radii, and the angle at the center is 180, and so angle subtended by these two chords will be 90, so this angle is 90. Another theorem we use is that the angle in a semicircle is 90 right here. This angle at L is 90, all right? This angle is 90, but what is this angle going to be? Now, what we're saying is that this triangle, all right, this triangle right here, radii, and so this angle is also 90. And so if this angle is 90, 90 and 50 is 140. And so if that is 140, then this angle is going to be 40. If this angle is 40, then we're almost done. Then that means that this little piece in here is 30. This little piece in here says 30. How do I know that? Opposite angles in a cyclic quad is 180. And so this little piece is 30. This is also 90. And so this piece is 30. This is 20. That's 50. Then this is 40. So this angle right there is 40. All right. That angle right there is 40. All right. All right. So we're almost there. This angle is 40. We want HKL. HKL. This angle right here we want. So no, this is 40. So let's see how are we gonna compose ourselves to end up getting this angle. Now, as we were saying, this angle is 90. And we said that this angle was what? This angle was 30. If that angle is 30, then this angle right here is, that is 30, this is 60, and then this angle is 120. So this angle right here is 120. If this angle is 120, look how many angles, as I'm saying, I'm doing it the long way. This angle is 120, then angles on a straight line is 180. And so then this angle is 60. If this angle is 60, all right, this angle is 60, then this angle in here is also 120. All right, so this angle in here is also 120. All right. Now this angle is also 90. How do I know that this angle is 90? All right, because this, all right, so this angle is 60, 120, 120. This is 60. Nice and easy. We'll find so many of the angles, all right? So what is missing to find? What is missing is still just the angle that we want, which is HKL, we know that this angle, we know this angle right here is 40. Oh my God, we didn't even need to do all of that. This angle is 40, all right? This angle is 40 because this is 90, all right? This angle is 40, how does that help? How does that help? So this is 40, and so 40 plus this angle at H, plus this angle should give us 180 because opposite angles in a cyclic quad sums to 180. All right, so that is that. All right, where else can we use Z angles? We know angles in the same segment are equal. So we need to utilize some angles in the same segment. Sometimes it's good to answer what you have. So let's answer what we have so far. JOK, JOK is 90. We're going to come back to this one very shortly. And so the angle JOK is 90. JOK is 90 degrees. Why is that 90 degrees? It's 90 degrees. It's 90 degrees right here because we have a radii and a diameter, all right? So this forms two right angle triangles. These are two right angle triangles. This is also a right angle triangle, all right? And so what we can say is since O is center of circle and HO and OK are radii, then triangle HJO and triangle JOK are right hand triangles. They are right hand triangles. All right. Hence, JOK is 90 degrees. That's that reason. Easy question. So JOK is 90 degrees. Now, since this triangle is similar to this triangle, all right, this triangle HJO and JOK are similar. So good right there. Good. Good. Now look at this now. Now triangle HJ to this point, I don't know what it is. It is clearly similar to L. So what am I saying? I am saying this point right here, we can give it a letter. We can call this point M. Let's reference that point as M. Let me put it out here. So what I'm saying then is HMJ. So I'm saying HMJ is similar. HMJ is similar. HMJ is similar to LMK. It's similar to LMK. So what does that mean? That means alternate angles in the same segment are equal. So if this is 120, this is 120. All right, then in HMG, this is 40. And so this angle right here is also going to be what? Of course, it's going to be 40. So this angle over here is 20. So the angle at K is 40. All right, so this angle right here is 40 degrees. All right, what are we going to use? Angles in the same segment that are subtended by the same chord is 40 degrees. All right, and so angle HKL is 40 degrees. Nice and easy. If this is 40 and this is 90, then this here says 50. Angle at H is 50. Nice and easy. All right, so we'll find every angle now. So we're straight, I want nice. So nice, now we'll find all of the angles. So what is JHK? JHK, which is right here. So it's also 40. JHK is also 40. This is also 40 degrees. All right, and you'd have to trace back to all of the reasoning that we were using. How did we end up get this is 40 degrees? We got that this was 40 degrees from, let's trace back our steps. This was 90, this was 30, this was 20. Angles in a triangle sum to 180. That's how we ended up getting that one. Angles in a triangle sum to 180 degrees. And so we were saying that JHK is equal to 180 minus that 90 plus the 20, 90 plus the 20 plus the 30. So that's how we end up get that to be 40 degrees. So this was a very easy question. Nice. I'll finish that. And now move on to the final question of the paper. Question 11. Oh, no, my apologies. I really want to get to the final one, matrices, but we're at part B in question 10 now. Part B. So part B in question 10 gives us this, and it says a ship travels from Akron on a bearing of 30 degrees to Belleville and 90 kilometers away. It then travels to Compton, which is 310 due east from Akron, as shown in the diagram below. Indicate on the diagram the bearing 30 degrees, 90 kilometers, and 310. So the bearing of A, so a ship sails from Akron on a bearing of 30 to Belleville. So the bearing of A from B, this is 30 degrees, that right there, so it's 30 degrees. Then they tell us that the distance from A to B is 90 kilometers. So the distance right here is 90 kilometers. Let's try to make it better, fit in 90 kilometers. The distance is 90 kilometers from A to B, and then it says it then travels to Compton 310 due east of Akron, as shown. All right, so it travels 310 right here, 310. This is 310 kilometers as well. All right, that's 310 kilometers. Now it says calculate the nearest kilometer of, oh, which is due east from Akron? Sorry, so 310 should be right here. My apologies. AC is 310, a matter of fact. Now they're asking us to find out what is BC. Now, it's easy to find BC. This is such an easy question. Now, if this angle is 30, then right here, inside here, this angle is 60. All right, this angle is 60 because angles in a right angle sum to 90. So this angle is 60. If this angle is 60, to find BC, we're going to use cosine rule. So BC squared. Well, you don't even need to use cosine rule. You could actually But I want to use cosine rule. So BC square is going to be equal to A square, which is 90 square, plus 310 square, 90 square plus 320 square, minus 2 times 90, minus 2 times 90, times 310, 2 times 90 times 310, times the cosine of 60, times the cosine of 60 degrees. And so that's BC square. So if that's BC square, what it works out to be is BC square is equal to 90 square plus 310 square minus 2 times 90 times 310 times the cosine of 60. So that's 76,300. That's BC square. 76,300. So now that BC square is 76,300, we square root it to find what is BC. I want it to the nearest kilometer. So when you square root it, you get BC is 276. BC is 276 kilometers. That is BC, 276 kilometers. Now that BC is 276, it says calculate to the nearest degree the angle ABC. To find angle ABC, you can use cosine rule, or you can go ahead and use sine rule. I'm going to use sine rule. Using sine rule, I'm going to say the sine of ABC, sine ABC over that 276, sine ABC over 310, it's going to be equal to I know sine 60 over 276. Sine rule. So angle ABC will be equal to ABC. Just to show it's an angle, let me put the hat over B. Angle ABC is sine inverse of, going to be sine inverse of 310 sine 60 over 276. So it's 310 sine 60 over 276. That's what we're working out. So angle ABC works out to be 310 sine 60 divided by 276. Then we take sine inverse. You want it to the nearest degree, and so I'm getting 77 degrees. This is 77 degrees. Nice and easy. So angle ABC is 77 degrees. Nice. Then it says determine the bearing of Compton from Belleville. So I'm going to put it on the diagram now. So this angle is 77. Determine the bearing of Compton from Belleville. So they want the bearing of C from B. So the bearing of C from B is going to be, now I always like to split it, all right? The bearing of C from B is going to be this angle right here, all right? So if this is the angle of, C from B inside here, all of this angle is 77, all right? The bearing of B from C. So all of this angle is it. So it's going to be, it's pretty much 90 plus something. this small piece in here. All right, this small piece in here. Now, how are we going to find this small piece in here now? Now, there are many ways to find that small piece. All right, now, Z angles are equal. Z angles are equal. So what do we know? We then know that this angle, we know this angle is 60, this angle is 30. If this angle is 30, then this piece is 47. That piece is 47. That piece is 47. So if that piece is 47, what do we know? This is 47. If this piece is 47, then we know that this is 180 minus 47. So that's the bearing, 180 minus 47. So the bearing of C from B is going to be 180 degrees minus 47, which is equal to 133 degrees. Again, you might wonder how I got the 133 degrees. Now, Z angles are equal, so this angle is equal to the angle in here. This and this are equal, 60 and 60. All right, good. Now, the whole of this is 77, and so this angle right here is 47. But the bearing of B from C is all of this, but angles on a straight line is 180. And so this side is the angle that we want, and this angle that we want is 133. And we're done. Nice. Question 11.